Let's have it to be solution if you are ready. Now, such that a does not equal to 0. So from here we have 2 to the power of a times, we can have this 4 in base 2 as 2 to the power of 2 to the power of a, because we can have this in base 2 also, 2 to the power of 3 to the power of a. So from here we have 2 to the power of a plus this, we can have it as 2 to the power of 2 times a will be 2a. We can have this as 2 to the power of 3a, because from the law of logarithm, when you have a to the power of n to the power of n, can be simplified as a to the power of mn. So from here, we are going to have this as, and likewise, we can also interchange this to be a to the power of n to the power of n back. So applying it here, we have 2 to the power of a plus 2 to the power of a in parentheses to the power of 2 equals 2 to the power of a in parentheses to the power of 3. So we have 2 to the power of a in common, so we can define them to be, let 2 to the power of a equals x. So from here we are going to have it to be x plus this will be x squared equals x to the power of 3. Now, by taking the whole of this to this side, we are going to have x to the power of 3 minus x squared minus x. So we set the other side to be equal 0. What is common between them is x. Factor it out. X to the power of 3 divided by this will be x squared. This divided by this will be minus x. This divided by this will be minus. This divided by this will be 1 equals 0. Now, what we are saying is very clear. Is either we have x equals 0 from 0 product rule before we can have this expression to be equal 0, or we have x squared minus x minus 1 equals 0. Now let's solve them by, let's say, case 1. Then let's have this as case 2. Now, recall that s equals 2 to the power of a. So we say 2 to the power of a equals 0. And we tell ourselves that from here, when you have this, let's have the log of both sides. This will be log 2 to the power of a equals log 0. Then from here we have a multiplied by log 2 equals log 0. Dividing through by log 2. So we have this cancelled out. We have a equals log 0 over 2 is 0. So we say it does not equal to 0. So we reject this. Then let's solve this quadratically by defining the following parameter a to be the coefficient of, let's solve them as x minus b will be the coefficient of x, which is minus 1. So here will be plus 1, positive or negative, root of this will be 1, then this will be 4 times minus 1 over 2. So we have x, 1, positive or negative, root of this will affect this will be 5 over 2. So we have x can define x1, 1 plus root 5 over 2. We can define x2, 1 minus root 5 over 2. Now, to check, we have to recall that we have x to be 2 to the power of a. When we consider x1, 2 to the power of a, we have 2 to the power of a equals 1 plus root 5 over 2. By introducing log, 2 to the power of a equals log 2 to the power of 1 plus root 5 in base 2. So we are going to have this in base as a multiplied by log 2 equals log 1 plus root 2 over 2. Dividing through by log 2